You've been alive for roughly 10,000 days. Pick any one of them. Not a birthday, not a graduation, just a random Tuesday from 3 years ago. You can't. Most people assume memory works like a camera. You live something, it gets recorded, it sits in storage somewhere in your brain waiting to be retrieved when you need it. That's not what memory is. That's not even close. What actually happens to the days of your life is far stranger than anyone tells you, and once you understand it, the way you think about your own existence will never quite be the same. In 1885, a German psychologist named Hermann Ebbinghaus did something no scientist had done before. He spent years memorizing thousands of nonsense syllables and then systematically tested himself to track exactly how fast he forgot them. What he mapped became known as the forgetting curve. The results were brutal. Within 1 hour of learning something new, you've already forgotten roughly half of it. Within 24 hours, 70% is gone. Within a week, close to 90%. Not faded, not blurry around the edges, gone. Now you might think this doesn't apply to real life. Nonsense syllables are different from actual experiences. You remember things that matter. But here's what's fascinating. You don't get to decide what matters. Your brain does, and it makes that decision before you even realize it's happening. Neuroscientists call it memory consolidation. When you experience something, it doesn't immediately become a long-term memory. It exists first as a fragile electrical signal, temporary, unstable. For it to survive, it has to be physically transferred from your hippocampus, where it was born, into your cortex, where long-term memories are actually stored. That transfer happens during sleep, specifically during the deep, slow-wave sleep in the first half of the night and the REM cycles that dominate the second half. If that process doesn't complete, the memory doesn't make it. Not weakened, not distorted, gone. In 2019, neuroscientist Matthew Walker at UC Berkeley published research showing that even partial sleep deprivation, losing just 1 or 2 hours on a single night, can reduce your brain's ability to consolidate new memories by up to 40%. 40%, which means nearly half of what happened to you yesterday might already be unreachable. Not because anything went wrong, because that's just how the system works. But here's the part nobody talks about. Your brain isn't just failing to save your memories, it is actively deleting them. Every night while you sleep, your brain runs a process called synaptic homeostasis. During the day, as you experience things, the connections between your neurons, your synapses, grow stronger. They encode what happened. But if every connection kept growing indefinitely, your brain would eventually overload. The system would collapse under its own weight. So at night, it prunes. It strips back the weakest connections to reset the baseline. It decides which signals are strong enough to keep and which get cleared away to make room for tomorrow. You were never consulted. You never agreed to this. It just happens every single night. Your brain edits your life while you sleep, and the editing is ruthless. So what actually survives? Researchers studying autobiographical memory have identified something they call the reminiscence bump. If you ask adults to recall memories from across their entire lives, a disproportionate number cluster between the ages of 15 and 25. Not childhood, not middle age, not last year. That narrow window of adolescence and early adulthood. Psychologists believe this happens because that period is saturated with novelty. First love, first real failure, first time feeling like a person with a future. Your brain flagged those experiences as high priority. Everything else got lower billing. Which means the vast majority of your life, before 15 and after 25, is being quietly compressed, averaged out, discarded. Think about what that actually means. You have lived thousands of days, felt thousands of things, had thousands of conversations that felt important in the moment they happened, and most of them are simply no longer anywhere. Not locked behind some door your brain can't open, not stored on a server you've lost the password to, just gone. Now here's where it gets uncomfortable. In 2013, a team at MIT led by neuroscientist Steve Ramirez did something that sounds almost impossible. They identified the exact neurons in a mouse's brain that held a single memory. Then they used targeted pulses of light to artificially activate those specific cells. The memory fired. The mouse responded as if it was reliving the original experience in real time. The memory wasn't erased. It was physically encoded in specific cells. The mouse just had no way to reach it on its own. Some researchers believe human memory works the same way, that many of what we call forgotten memories aren't truly gone. They're inaccessible. The pathway to retrieve them has degraded or been rerouted. The memory sits somewhere in the dark with no road leading to it. But whether those memories still exist or not, the result is identical. You cannot reach them. You will never reach them. Those days are gone. So here's the question that actually matters. You will wake up tomorrow and live another day. Your brain will capture fragments of it, the emotionally charged moments, the novel experiences, anything it judges worth the metabolic cost of keeping. And it will quietly discard the rest. Most of tomorrow will be unreachable by next week. Almost all of this year will be unrecoverable by the time you're old. And knowing that changes something. Not because it's depressing, because it forces a question most people never think to ask. If your brain is going to forget most of your life regardless, if the pruning happens every single night whether you want it to or not, then the only days that survive are the ones vivid enough, strange enough, or meaningful enough to pass the filter. You don't remember ordinary Tuesdays. You never will. Your brain already knew that. The question is whether you do.